Hi guys, in this video I will show you SVGAssets, a Unity native plugin for reading and for rendering SVG files on texture objects at runtime. The package includes a standalone SVG player based on the SVGAssets technology in order to test SVG assets before to use them inside your projects. The plugin supports several platforms, including Android or MIPS X86, iOS 7, MacOS X, X86 Windows and Linux, 32 and 64 bits. The package includes a simple Unity example showing the usage of this SVGAssets plugin that I'm going to show you in a minute. The sample project contains the native libraries and the set of C# scripts. Before to start with the Unity example, let me show you that SVG files are rendered by our technology correctly. First, I open the Zodiac Gemini SVG with Safari. Now I open a manga style SVG. Good. Now let's run our standalone player for OS X. The About dialog shows you some information about the SVG library, and now we open the same Zodiac Gemini file seen before. Okay, it works really fast and we got an excellent quality. As you can see, our player shows the document with the correct transparency and, most important, the viewport specified in the SVG file. For a quick comparison, we can use Safari browser to see how the same SVG is rendered. The drawing is correct, but Safari rendered it on a white background, so we have no idea about the transparency. Let's open Unity Editor with our simple example already loaded in. You can find it in the sample subdirectory of SVGAssets package. The scene is made of a square plane and a camera pointing it. Now I select the plane and I add a script component. I choose the SVG texture behavior from the drop-down menu, and here we are. Public properties of the script allows you to select the SVG file to render, the texture resolution, and the background clear color. Now I drag and drop the Zodiac Libra SVG and set a texture resolution of 128 pixels. Let's click play and see what happens. As expected, the result is a lower rendering. 128 pixels are too few for the physical dimensions that we are targeting. Raising the resolution to 512 pixels, we definitely get a result in line with our expectations in terms of visual quality. If we want a transparent background, we just need to set the clear color alpha to 0. The plugin supports full 32-bit RGBA surfaces. Reset the color to the default white, and now we can take a look to the code part. The plugin consists of a native library called SVG and a C-sharp interface made of several classes that simplify the usage of the low-level API. There are methods for creating drawing surfaces, load SVG documents, get their information, draw them on surfaces, and so on. The native library is written in C++. All the functions are very well documented directly in the code. The C-sharp interface exposes classes for the manipulation of colors, viewports, drawing surfaces, SVG documents. In order to show you the C-sharp interface, the minimal example consists of a mono behavior that takes an SVG file and renders it to a texture. Public properties in the script are the ones that we have already seen in the Unity editor. The drawSVG function takes the SVG file content, texture, dimensions, and a clear background color as inputs. Step by step, the function creates the texture with the specified dimensions, creates a drawing surface with the same dimensions, creates and loads the SVG document, renders the SVG document to the drawing surface, uploads the drawing surface pixels to the texture, and returns the created texture. As you can see, execution steps are really simple. The plugin is not limited to this use case. For example, with minimum efforts, it is possible to achieve a powerful resolution-independent texture atlas. Let me show how. First of all, we create a new text file, and as a good starting point, we can copy the previous script. We rename the monoBehavior class, adding the atlas postfix. Instead of having a single SVG file, in this example we want to render 4 different SVG files in a single texture, so we add 3 new SVG files properties. We modify the drawSVG function in order to take 4 different XML strings and load each of them in a separate SVG document. To accomplish this task, we need to declare 4 document variables. We load each XML string in a different document object. The string will be parsed and the internal document structure is created. Of course, we must take care of possible errors arising from SVG parsing and memory allocation. At runtime, if we got an error from the native library, we simply destroy all previously created resources. In the detail, we destroy all already loaded documents and the drawing surface. Because we are going to draw multiple SVG documents on the same drawing surface, the drawing function surface.draw is called 4 times. Obviously, we want to clear the drawing surface just once. In the first call, we specify a background color, in the others we set a null parameter. The clear color is taken directly from the monobehavior properties. At the end of the function, it is a good practice to destroy allocated SVG documents and the drawing surface. In the start section of the mono behavior, we must be sure that the developer has specified 4 different SVG files. So let's add this check. At this point, we want to draw each SVG document in a different section of the drawing surface. If you don't specify a surface viewport, at each drawing call, the whole surface is used. It's not our case. So let's define the first surface viewport as the top left texture portion. Each viewport is defined by its top left corner, a width and then a height in pixels. Now we define the second surface viewport as the top right texture portion. The third portion will be the bottom left and the fourth the bottom right. As you can see, all the parts have the same dimensions, equal to the half texture, width and height. Let's save the script and check the result in Unity. Let me perform the last checks. Okay, here we are. Oh, we got a compilation error. Let me check and fix it. Okay, it seems that all is right. We need to remove the previous script from the plain object and bind the new one. Now we drag and drop 4 SVG files in the component mask interface and then click play to see the result. We got an expected result: 4 SVG documents rendered in a single texture. The SVGAssets API is flexible enough to handle rotation and translation of the surface viewport. It could be useful to work with graphical assets that are not out of the box ready to use. Let me show you how to rotate the top left surface viewport in our example. We create an SVG viewport transform defining a pivot at the center of this portion. Then we specify a rotation of 90 degrees. We do not include a post-translation. Because we want to rotate just the first viewport, we need to reset the transformation to the identity for the other draw calls. Let's save the script and see the result in Unity. Okay, we have rotated by 90 degrees our Gemini SVG. If we wanted to rotate by 180 degrees, we can simply modify the relative parameter in the viewport transform. Click play again. Done. Thank you for watching this video. For additional information, please refer to www.mazatech.com. Bye!